Year 10 and welcome to today's lesson. I hope you enjoyed the live lesson last week, but today we'll be having a pre-recorded lesson. Tomorrow you'll be back with Miss Fingleton and continuing along with the same theme, but in a live lesson instead. In today's lesson we're going to start looking at simultaneous equations, and this will be our first lesson. You're going to have quite a few of those this week. This links into the topic we've been doing because once again it has a link to graphs, and it's also looking at algebra and solving and seeing how things coincide with others. To start today's lesson, can you go ahead and pause this video and have a go at the do now? Welcome back. Okay, I'm just going to look at question 1 and 4. To write something in the completed square form, where I've got no coefficient of x, that makes it a slightly easier question because I don't need to factorise anything first. So I don't need to worry about that part. Into the brackets, I write x and then half of the coefficient of x, so it's going to be plus 3, and that is then squared. Then I subtract this number squared, so I'm going to subtract 3 squared, and then I have to make sure I add on that number on the end still to keep this number in here. Simplifying this, I get x plus 3 squared, well minus 3 squared, well that's going to become 9. Minus 9 plus 9 is just going to be 0. So it's just x plus 3 squared. Having a look at question 4 now. Now this one, because it has a coefficient of x squared, I'm going to have to factorise it first because I want this to look like just x squared. To do that, I'm going to take out a factor of 2. And I like to write big square brackets to help me here because there's quite a few brackets involved as we go through. Factorising out 2 from this term just leaves me with x squared. Factorising out 2 from here, well, I'm doing 9 divided by 2. Well, what am I left with? Well, a fraction of 9 over 2. If I was to multiply 2 by 9 over 2, I'd be left with 9. That gives me 9 over 2x. And then I personally choose to close those brackets here and just leave this number on the end. This number doesn't really bother me what it is, so I like to deal with that later. Now that I've factorised this, this looks like something that I can complete the square on. There's no coefficient of x squared. Quite nicely, there's no c, so I've not got to worry about that part. So now what I want to do is complete the square on this section here. I'm going to leave that 2. And those big square brackets. Then opening brackets, I want x plus half of this number squared. Now if I take half of this number, it's simply going to be 9 over 4. And then I can close those brackets. That bracket must be squared, then I need to subtract this number squared. Well, that is subtract 9 squared is 81, 4 squared is 16. Close those square brackets because I've dealt with all of this now, and I've still got that plus 9 on the end. Now what I want to do is expand this 2 and these square brackets. I'm going to do 2 times everything inside the square brackets. 2 times this here is just going to be 2 lots of the bracket squared. 2 lots of this number here, well, if I do 2 times a fraction, if I simply halve the denominator, that's the same as multiplying by 2. I could multiply by 2 for the numerator, then take out a factor of 2, or a quick step is to just take the 2 and divide this number by it. So do 16 divided by 2, give me minus 81 over 8. And I've still got that plus 9 on the end. The last thing I want to do is combine these 2 terms. So I'm going to do that over here. I've got minus 81 over 8 plus 9 over 8. Sorry, it's not over 8. I want to make my denominators the same, otherwise I can't add them. To do that, I need to multiply this one by 8 over 8. So I'm going to have negative 81 over 8 plus 72 over 8. When I combine these now, I'm left with minus 9 over 8. So my final answer is 2x plus 9 over 4 squared minus 9 over 8. If you're not sure on any of these questions, I suggest that you go back to last week's lessons and double check those videos. You've also got access to Hegarty, where he will also explain stuff and give you access to quizzes. Okay, so there are all your answers. Okay, as I mentioned previously, we are going to be looking at simultaneous equations today. It'll be our first lesson on that. Sorry, this shouldn't be here. I haven't deleted that from last lesson. Can you please write down today's date and title and just take a note of those key words? Those are words that you're going to hear me use quite regularly in today's lesson. Okay, so the question is, what are simultaneous events? If I know what simultaneous events are, I can apply that to equations. Well, two events happening at the same time are simultaneous. So simultaneous means happening at the same time. So for example, the ages of two people this year, the ages that two people will turn, it's happening within the same year, it's happening at the same time, so they are simultaneous events. We could also go to the shop and look at the price of an apple and a banana now. So right this second, what do those two things cost? Those are simultaneous things, they're happening at the exact same time. So we can write equations that link two events. Now, often you'll find that they're just in terms of X and Y, but they could also be in terms of the price of apples and bananas. It could be the price of CDs and DVDs. We can write it in lots and lots of different ways. But if we have the two equations, we can sometimes then work out what the price of those two things are, or what the values of those two events are. A linear equation, and those are the ones we're going to look at today, is an equation between two variables that gives a straight line when plotted on a graph. So when we're looking at simultaneous linear equations, if this is my graph, X and Y go this way. If I have one line there, and that could be expressed, it's very close to Y equals X. And I have this line here, well this looks like about, and it's just an estimation, Y equals minus X plus 2. These are linear equations, they're simultaneous because they're happening at the same time on the same graph. And if I was to solve the simultaneous equations, what you're actually finding is that point there, the point at which they cross. Now, not all lines will cross. For example, if we had my axes up here and I had these two lines, well, they're parallel. Okay, they are simultaneous, but they don't cross. They're parallel, they'll never meet. So when we're looking at solving simultaneous equations, we're looking at lines almost always with different gradients, and we're finding the point at which they cross. Now, they may be written like this. They may also be written slightly differently, and we're going to look at a variety of different types today. Okay, so if you were to look at this equation here, just pause the video here and I want you to write down 5 different pairs of numbers, pairs of X and Y that satisfy this equation. Okay, so I come up with 1 and 9. I could have 2 and 8. I could have 3 and 7. But I didn't even say they had to be whole numbers or even positive. I could have minus 2 and positive 12. I could have a half, and I could have 9 and a half. Okay, there are a wide variety of numbers that will satisfy that equation. What about this one? Could have 5 and 1, could have 6 and 2. But again, we could have some negative numbers. For example, I could have 3 and negative 1. When I do 3, take away negative 1, becomes 3 plus 1, which becomes 4. So again, there are a wide variety of numbers that you could choose. What about a pair of numbers, though, that will work for both of these equations? Now, by trial and error, you could work this out, and I'm sure that's what you guys have been doing right now. However, there is a quicker way, which we are going to look at today. But for now, I'm just going to give you the pair of numbers that satisfy this. If we have 7 and 3, we get 10, and 7 take away 3 will give me 4. And that is the only pair of numbers where this works. So when we're looking at one equation on its own in terms of X and Y, there are lots and lots of different solutions. But when we combine that with another equation, and these could be drawn as two different graphs, we create exactly one pair that works. So as I've discussed, we could draw these on a graph and we could look at the point where they touch. However, drawing a graph can often take quite some time, and it would be preferable to find a quick way to do it without having to draw a graph. And that's what we're going to do today, is look at how to algebraically solve these equations and find the point where those two straight lines touch. So the first way to do it is by substitution. Okay, that means where I take one of the equations and I substitute it, I swap it into the other one. Now that is really, really helpful when you're given two equations that look like this. One of them is an addition of two variables, but the other one is that one variable is equal to some expression of the other. But because I know y is equal to 2x, wherever I see y, I can write 2x. So I'm going to substitute equation 1 into equation 2. Where I see y, I just write 2x because I know that y is equal to 2x. So this becomes plus 2x, and that is still equal to 6. Combining like terms, I now get 3x plus 6, equals 6. And you'll now notice that I have an equation with just one variable. This I can now solve. Dividing by 3, I get x equals 2. So I've divided by 3 there. So when x equals 2 is one answer, but I also need to know what does y equal. Well, y is equal to 2x, so y is equal to 2 times 3, y is equal to 6. So you want to substitute equation 1 into equation 2, which will create equation 3. Then I want you to solve equation 3 and then substitute back into equation 1. If I was to write those down as steps, substitute equation 1 into equation 2, and this will equal equation 3. Solve equation 3, substitute back into equation 1. Then finally, you want to write your answer as x equals 2 and y equals 6. I'm going to ask you to pause the video here and write down this as an example. I'd also like you to write down these steps. In a moment, those will disappear, and then I'll give you a chance to have a go at one on your own. Okay, have a go at the one on the right. We have equation 1 and equation 2. I want to substitute 1 into 2. I know that y is equal to 3x. So I'm going to have, wherever I see y, I'm going to write 3x. And that's equal to 5. This is now created equation 3. I'm just going to combine like terms to get 5x equals 5. This is equation 3. I now want to solve equation 3. If I divide by 5, I get x is equal to 1. And then finally, I want to substitute back into equation 1. So I'm going to rewrite out equation 1, which is y equals 3x. Substitute in x, y is equal to 3. My final answer is x equals 1, y equals 3. Okay, what happens though if this number here is negative? What happens? I'm going to follow the same steps to start with, and we'll see what changes as we progress. So I've got equation 1 and equation 2. I want to substitute equation 1 into equation 2. So I get 3x minus 2. Now this is different as well. This time there's a 2 next to the y. So I'm still going to write minus 2. And where I see y, I'm going to write in equation 1. I'm going to choose to put it in brackets. So it's minus 2x. This is equal to negative 7. Now I've created equation 3, but I want to tidy it up a little bit. I've got 3x And then I've got minus 2 times minus 2. Well, 2 times 2 is going to give me 4. A negative times a negative is going to give me a positive. That's x, and this is equal to negative 7. Once again, I'm still tidying this up, I'm not solving it just yet. I get 7x equals negative 7. Now I can solve it, divide by 7 and divide by 7 to get x on its own. X is equal to negative 1. I need to make sure I substitute this back into equation 1 to be able to get an answer. Y is equal to negative 2x. Y is equal to negative 2 times negative 1. So therefore y is equal to 2. My final answer, x equals negative 1, y equals 2. Please pause the video here and write this down as an example. And have a go at the one on the right. There are your answers. Okay, alternatively, we might not just have that y is equal to x, or y is equal to 2x, or 3x, or negative 3x. We could have a full expression. Okay, in this case, it's x plus 2. So I'm still going to follow the exact same steps by substituting this where I see y. So I'm going to do x plus, wherever I see y, I write all of this. Now I would always write it in brackets, just in case there happens to be a number here. It's helpful to write this in brackets every single time. And this is equal to 20. Now I now get x plus 2 is equal to 20. Combining like terms, I get 2x plus 2 equals 20. Solving this equation, I'm going to subtract 2 from both sides to get that 2x on its own. Then I'm going to divide by 2 to get x is equal to 9. I need to make sure I substitute this back into the equation up here to find y. Y is x plus 2, so y is 9 plus 2, which is equal to 11. My final answer, x equals 9, y equals 11. Please pause the video and write this down as an example. And have a go at the one on the right on your own. Be careful, this time you're going to have to make sure you've got a 3 and then open the brackets to write in y, and you'll have to expand that before you can solve it. There are your answers. Okay, this is our first task today. It's got a slightly longer lesson than usual with a few different activities to do. Can you please pause the video here and have a go at these questions? And there are your answers. Now the only one I'd like to have a look at is H down here. Okay, it's all the questions said to solve by substitution. However, you can't immediately solve this one by substitution because I can't substitute in x because I don't know what x equals. I can't substitute in y because I don't know what y equals. What I want to do is rewrite this as something as y is equal to. Okay, I typically choose to substitute in y. There's no particular reason for it. So to rewrite this as y is equal to, I'm going to subtract 4x from both sides to just get 2y. I'm going to subtract 4x. This is going to leave me with 2y equals 32 minus 4x. I also then want to divide by 2 to get y on its own. Now remember, it's this entire right-hand side you're dividing by 2. So I'm going to do 32 divided by 2 is 16, and minus 4x divided by 2 is minus 2x. Now that I have that y is equal to 16 minus 2x, I can substitute that into this equation down here, and then I can solve. Okay, alternatively, you may choose not to rearrange something, and that is absolutely fine, and that's not always the thing you need to do. There's another method to solve simultaneous equations, and that's by cancelling. That means I take my two equations, and I will cancel something out by doing some addition or some subtraction. Now, it seems a strange thing to do, to add two equations or to subtract two equations, but it is in fact allowed because it allows us to cancel things out. And as long as we know that these are simultaneous and that they are happening at the same time, we are perfectly okay to add and subtract them. Now, as I said, I want to be able to cancel one of these things out. I want to create a new equation. So I'm going to either add or subtract. I haven't decided yet. I want to add or subtract these so that when I get down here, this equation here is going to equal a number, and I'm just going to have one variable on the left-hand side, just one letter. I don't want x and y, I want either x or y. Now, to do that, if I was to do 5x take away 2x, well, that leaves me 3x. If I do y take away y, that's going to leave me with no y, so that works. If I was instead to add, this would create 7x, and this would create 2y. So that would create a new equation that I wouldn't like to use. So I'm going to choose to subtract, because when I do y, take away y, they're going to cancel each other out, and I'm going to be left with just x. So I'm going to choose to subtract so that my y's cancel out. 5x, take away 2x, leaves me with 3x. Y, take away y, well, that leaves me with no y. 20, take away 11, leaves me with 9. So what I've done there is I've just taken the first equation and I've subtracted the second, looking at each term in turn. Solving this, I'm going to divide by 3 to get x is equal to 3. The only other thing I need to do now is to substitute this back into one of those two equations to solve for y. Now this part here takes a little bit longer because it's not as simple as y is equal to something. I'm going to have to substitute in and then rearrange, but that is absolutely fine. I typically just choose the first one. No real reason you can use either one. So I'm now going to have 5x plus y equals 20. Substituting in x, I get 5 times 3 plus y is equal to 20. This is 15 plus y equals 20. Subtracting 15, I get y is equal to 5. So my final answer is x equals 3 and y equals 5. Now the great thing about this method is because I re-substituted back into the first one, what I could now do is substitute 3 in for x here and 5 in for y here and check to see if I get the correct answer. If you do, you know you solved it correctly. Okay, please pause the video and write this down as an example. And have a go at the one on the right. Once again, I'm going to choose to subtract these because y, take away y, is going to give me no y. 5x take away 2x gives me 3x. Y take away y gives me no y. 31 take away 13 is going to give me 18. Dividing by 3 to solve for x, I get x is equal to 6. Substituting this back into one of these two equations, I'm going to choose to use the first one. 5x plus y is equal to 31. 5 lots of 6 plus y equals 31. 30 plus y equals 31. Y is equal to, when I subtract 30 from both sides, y is equal to 1. So what these two examples have hopefully shown you is where the sign is the same, we're going to subtract. Therefore, where the sign is different, but we still have the same number of each, so we've got 2y here and 2y here, we've got one's add and one's subtract. Where it's different, we're going to add them together. So the signs are the same, we subtract. Where the signs are different, we add. 7x plus 3x creates 10x. 2y add negative 2y, they cancel each other out. 32 plus 8 is 40. This tells me that x must be equal to 4. Substituting back in, gives me y is equal to 2. Okay, pause the video and write down the example, then have a go at the one on the right. There's your answer. Okay, I'd like you to pause the video here and have a go at these questions. Now, if you're not too sure on these, I'd like you to start with level 1. But if you're quite confident, then I am allowing you to go straight ahead onto level 2. And then once you finish level 2, you can move on to level 3. So if you're not too sure, I want you to start at level 1 and go all the way through. If you're quite confident, then start on level 2 and then finish all of the questions. And here are the answers. Okay, make sure you have marked your work and please make sure you take a photo and upload that onto Frog. I also want you to make sure that you complete the Frog quiz because that's the easiest way for us to track how well you're doing on these topics. Now there's one thing I'd like to talk about before I end this video. Coming up next week, it'll be next Monday actually, is the UKMT Intermediate Maths Challenge. Now some of you will have taken part in this last year and some of you may have also done the junior one in year 7 and year 8. The Intermediate Maths Challenge is a 60-minute multiple choice competition for students in the UK. It's going to encourage your mathematical reasoning, precision of thought and fluency in using basic mathematical techniques to solve interesting problems. Quite a lot of the time what we do in maths is a lot of learning skills and every now and then we'll get onto a little bit of problem solving. What this does is it takes all the skills you've learnt before and it applies them in really nice, quite tricky sometimes, problem solving scenarios. It's really, really good for making you think not just about individual topics in maths, but tying them all together and seeing what you can do. Now, they award certificates for gold, silver and bronze, and the top 1,200 performers in this challenge, so the ones who got gold, not quite all of them, but most of them, will go on to compete in the Mathematical Olympiad. Okay, so you will compete in a slightly different style of competition. Now, I really, really do encourage you to take part in this. It is completely optional. I'm not forcing you to. There is no cost involved. There is a slight cost that the school will cover. Okay, so all you need to do is make sure that you turn up to do it. Now, we are holding it on the 1st of February next week on Monday at 3 p.m. Originally, I did say 2 p.m. in the advert that some of you have seen. I've had to push it back till 3 because you no longer have a maths lesson at 2. Okay, so if I did it at 2, that would coincide with another lesson, which I don't want to do. So it's now at 3 o'clock on Monday. Where will you do it? Well, typically we would have done it in school. I'd have got you all into the sports hall. However, we can't do that. So you will be able to sit the challenge online at home on a computer. If you want to take part, can you please fill in the Google form of the UKMT assignment on Frog? Okay, that's going to allow me to collect a bit of information, including your name and surname, whose maths class you're in, and also your school email address. Your email address is really, really important, as well as your name and your surname, because I need to create usernames and passwords for you guys, and then I will need to email those out. Now, deadline for replying to take part was originally last Thursday. However, UKMT have allowed us a little bit longer to apply for entries. So the deadline now is tomorrow at 8 p.m. Okay, I need to see your Google form. I need that information from you by 8 p.m. tomorrow if you'd like to take part. As I said, there is no pressure to, but I think it'd be really, really good for you to practice some of your problem solving skills. And it will also be a slightly different way of having a go at maths in the current lockdown. Okay, hope you have a lovely rest of your day and I will see you later in the week for our next pre-recorded lesson.